Good afternoon and welcome along to Glasgow Science Centre's Curious About Our Planet live Q&A sessions. My name's Ross. I'm one of the science communicators with Glasgow Science Centre and I'm joined by mechanical engineer John Bowman of Tidal Marine Power. John should be waiting for us. Sorry, John, I realised I just got...
Close. Orbital Marine Power.
Orbital Marine Power. Good start there. Just before we hear from John, folks, this is a live stream. We've got lots of questions, hopefully from yourselves throughout this. If you do have any questions that you want to ask John, feel free to leave any that you might have in the YouTube comment section, or you can tweet us at GSC1 and we'll get through as many as we possibly can during this session. But until then, John, I believe you've got a presentation for us, so please feel free to take it away.
Thank you very much. Hello everybody. My name is John Bowman. I'm a mechanical engineer with Orbital Marine Power, and we are a company that is making tidal turbines. So these are kind of like wind turbines, but they go out into the water and they operate as the tide comes in and out. It's quite a new technology that we're working with. It's quite a new area of development, and there's quite a lot of research and development been going into this recently, and we believe that we have the ideal solution and the biggest, most powerful turbine that there is in the world at the moment. So let's go forward. So we go to the next slide now, and that's it. That's the O2 turbine. So it's the most powerful floating tidal turbine in the world, and it's based up in Orkney. Now, there we go. Should be a wee map coming up. So that is where Orkney is, and the turbine is up there. Now, the reason that the turbine has been put up there is that there's a centre for development up there called EMEC, and it's the European Marine Energy Centre. And it's based there because they have some of the fastest tides in the world up in Orkney, as the Atlantic Ocean comes and sweeps around the top of Scotland and fills up the North Sea. The water depth up there is around sort of 35 to 50 meters, so kind of about the same as 5 houses sitting on top of each other. That's how deep it is, and that's where we put our turbine for testing. So if you go on to the next slide. So just to give you an idea how big it is, because it's kind of hard to see how big this turbine is just from that previous picture. Here it is sitting between a normal sort of EasyJet sized Airbus A320 and the giant Airbus A380. So you can see it's very big. It's 72 meters long. It's around 40 to 45 meters, depending on if you're taking the blades or not, wide, and it weighs in at 680 tons. So it's quite a heavy machine, but it's packed with really good technology. So I've got a small video now to show you about there it is. About the turbine.
We wanted to create a new vision, and we're willing to dream of things that never were. We were prepared to challenge conventional thinking, and we wanted to inspire. We just want to do as much as we can to help turn the tide on climate change. It's that simple. Inaction is not an option. world needs to change to survive. And we want to play a positive part in that. This is just the start.
Within that video, you would have seen the whole turbine going through the build and all the parts that went into building it. So from some of the gearboxes with the gears going round at the very beginning, there was robotic arms, there was welding, and then we had the massive structure floating off into the River Tay at Dundee, where it was towed all the way around with a small boat all the way to Orkney. And then at the end there, you saw how fast the tide is. So that last image, the turbine is stationary, it's not moving, and it's the water that's going past it really quickly. So we can go on to the next slide now, please, Andy. Yeah, there we go. So back in 2018, we had our first 2 megawatt machine. It wasn't our first tidal turbine machine, but it was our first 2 megawatt machine that went into the water. And it was in the water for 12 months as a testing prototype. And it met up to 25% of Orkney Island's electricity demand. So that's quite a lot of houses that are on Orkney, and businesses, and restaurants and everything, and it made 25% of the demand there. The turbine that you just watched was called the O2, the Orbital O2, and we've been making that for 18 months in Dundee, with design work going on for probably about 2 years before we started building. And then, yes, it's now been in the water for about 6 months, and we're nearly up to full generating capacity, which has been a fantastic thing to be part of. And in the future, we're hoping to build a lot more of these turbines, because they produce really clean, green energy that goes right into the grid, into powering your home, your neighbours' houses. It can be used for electric cars, and we also are currently involved in a project for creating green hydrogen as well, which can be used for a variety of different aspects, including powering cars and using in boilers in your house and things like that. So we have a real drive to try and put this in place. So you can see there how the turbine operates in that slide, where it sits in the water. You can see a line going all the way down the turbine there, and that's the water line. And then you can see it with the legs up and then with the legs down. So when the legs are up, we can access the hole in the cell, the blades and everything. We can go in and make sure that everything is working perfectly. And then when the legs are down under the water, that's when we're generating electricity, and that's when the rotors start turning, and that's when we can extract energy from the tides. Okay, we'll move on to the next slide. And yeah, this is just another few images of the same turbine, as you can see there, with a few more details. But just you can see some of the complexity down in the right-hand corner there of the retraction system, which operates like a giant hinge mechanism, and that lifts the entire leg up to the surface so that we can get access to it, and then lowers it back down again so that it's in the perfect spot for extracting the energy from the tides. So this is it on the barge just as it was leaving Dundee. Quite a cool picture with the bridges in the background. It's quite a complicated structure to maneuver on land because it's designed for the water. But this was a really exciting day for us when we managed to launch the turbine into the Tay for it to go up to Orkney. The day was absolutely perfect. The weather was fantastic for us. We couldn't have asked for better on that day. And so what you see there is that we drove it onto the barge, which you may have seen in the video just a wee while ago. And when it was onto the barge, we tied it down, and then that barge actually sinks below the water. So it can go down and down and down, and then the turbine just starts floating, and then we can pull it away. And that's how we put the turbine into the water. So you'll be able to move on to the next slide there. So you may have seen other turbines, other tidal turbines before, and these ones are generally mounted to the seabed. And our one's a little bit different because it's up at the very top. Now, why have we done this? Well, there's a few reasons for this. The tide is actually slightly faster at the very top, which means that when we're floating, we're actually in a faster tidal speed. So we're able to take more energy out of the tide and turn it into electricity. The other thing is that we can go out to our turbine in a really small boat if we wanted to and check up to make sure that everything's right, just the same way as you would take a car into the garage to make sure that everything was working okay with it. We can go out and do that with our turbine. And it's very difficult to do that at the bottom of the water. So those are the 2 or 3 different things that really we think give us a slight edge over everybody else, but it's also what makes our turbine really special. So it's, as I say, we can get access to it very quickly. We don't need one of these really big boats. Now, big boats mean that they're really expensive. You could almost pay £100,000 a day to hire one of those boats. And yet we can go out in just a small vessel, which maybe costs, I don't know, less than 1/10 of that. So there's some maths for you to go and work out how much that is. But there you go. But the great thing about this turbine is that it involved people from all over the UK. All of these different companies that you see up there doing very different things. So lots of the robots that we saw in the video at the start making the blades came from right down at the south coast of England. We had some welding happening in Fife. We had a lot of big heavy metal components being made at TSP in the north of England. The company that moved the turbine came from the north of England as well. We had all the electrical equipment coming from down south, and then we had the turbine was all assembled up in Dundee, as I've said before, where all the components were brought together. But a lot of the fabrication work, the welding and the machining and stuff of the entire body of the turbine was made in Fife, and then taken on a lorry all the way up to Dundee to be put together there. So it's a real variety of cool jobs that are happening all over the place to be able to put this turbine in the water. And we've had a lot of interest from around the world. We've had World Economic Forums, we've had BBC News, CNN in America, we've been on the TV in every country nearly. We've been China and across Africa. Lots of interest in this turbine as well. And if you go on to the next slide, you'll see a couple of special visitors that we had on the turbine as well, who came to give their blessing to it. And they're doing a tradition that we had there where we blessed the blades with some Orkney whiskey. So we splashed some whiskey onto the blades as a sign of good luck for the turbine. So you can skip on to the next slide and then on to the next one after that. Now, it's not just the giant turbines that we're looking to make. We're also looking at the future of other areas where we can make our turbines, and that would be these smaller river turbines. So there are so many places around the world that have got really fast flowing rivers through the middle of cities, and putting a small turbine like this into the river can extract some of the energy there that feeds directly into the city that the river goes through, and it can power the city really easily and really quickly from there and help to make cities a greener place for the future. So you can move on. So that's how the turbine might look in the future with for the river turbines. These would just be these would have an anchor system at the front there. You can see the two chains coming away from the front of that design, and again it operates in the same way with the legs coming up, so we can access it and then going back down again to get into the perfect zone in the water. So you can move across. One of the exciting things that I think that I take away from this was that this turbine at one point was just an idea in somebody's head. This was just, somebody thought, wouldn't it be great if this existed in the world? That this actually solves problems out there in the world. And by following that dream and following that vision and getting lots of people to come together and work on that, it's now a reality. We now have this turbine operating in Orkney, with dreams to put these turbines all across the world, around coastlines with high tidal speeds in a variety of locations. And I think that that's really, really cool. And it just shows how through engineering and ideas, and us all working really hard together on some of the ideas that maybe you even have in your head just now, that we can positively affect climate change. We can, make sure that we can make this world a better place for the future generations. So I think that's everything I have just now. So I'll hand back across to Ross and see where we go from here.
Absolutely. Yeah, I think we should have questions coming in shortly. That was absolutely fascinating, John. Thanks very much. I don't think I'd even realised the design. I don't think I'd given much thought. Other people might be the same about how a lot of tidal energy is actually generated. And just on to the point that you were saying before, the idea that came out of someone's head, at one point, someone's innovated it, because obviously on the seabed, it was one particular design, and someone thought, can we do this better? Which I think is quite an interesting point there as well.
Yeah.
Do we have our first question coming in for John, just to see if we do? Okay, so the first question, if you're ready, John, is from Anderston Primary School, and they want to know what inspired the design of the turbine.
I guess the inspiration came from the idea of having a floating structure to be able to take the energy out of the water. So there may not have been an initial idea that that's what we wanted to look like. Now, how can we do it? It more evolved naturally through a design process where we thought, right, here's a boat. A boat floats on the water. How can we attach something on the bottom of it to take the energy out? What's the simplest structure to make? It's a long tube, really easy, really strong way to build something. And then we asked, well, how do we get to the nacelles where the rotors and the blades are attached? Right, well, we'll bring that up to the surface. And so just over those small design changes, we've managed to come up with this design that we have today. And I'm sure that process will go on for a long time yet. This may not be the final design, but it's very close to it. So,
absolutely. Is it true to say that a lot of engineering is just by trial and error, and that's, like you were saying, we'll just go on forever and ever and ever?
Pretty much, yes. I think there's the thing with engineering, it's quite a beautiful thing in that, unlike certain sciences, there's no one correct answer. It's kind of an art form where there are lots of different competing things that we can do. And it's about trying to select the best ones. And sometimes the best one that you think on paper isn't the best one when you install it in the water. But when you put it in the water, you go, wouldn't it be great if we'd done this? And then it goes back to the drawing board and you try again. And you put it back in the water and you hope it does the job. Yeah, exactly.
And who knows, like the one just from your presentation with the ones that were generating power on the river, it could actually be potentially any school pupils that are listening just now that could be engineers in years to come that might actually be making that a better design.
Exactly. I hope so.
Cool. Do we have another question coming in? We do. Okay. We've got from St. Bridget's Primary. Just before we read it out, folks, remember that you can, just from saying before, you can put any comments that any questions that you want to ask into the YouTube comment section, or you can tweet us at GSC1, and we'll get those questions over to John as best we can. So the question coming from St. Bridget's Primary, they want to know, John, how fast does the turbine spin?
So the turbine actually spins quite slowly, which may not be what you were expecting. But if you see a wind turbine, it goes round quite slowly as well. So it follows the same sort of thing as that. It's about the same sort of speed, so maybe about 10 times per minute that it will go round. So it's not all that fast. And the reason for that is that what we're trying to do is that it's a thing called torque that we're working with, and we're trying to use the rotation to twist a shaft in an electrical motor. And that generates electricity when you turn the shaft instead of the motor turning the shaft. So if the slower but stronger that we can make that, the more electricity we can make. So it's kind of counterintuitive. You think it should be going round really quickly, but it's actually the slower process that generates a bit more electricity for us.
Is there any comparison to say, could you say what sort of wind speed would have to be going into a wind turbine to make the same amount of energy Or is that a good comparison, or is that a one that's really...
I mean, they work on the same principle.
Okay.
The blades will, so generally a blade will rotate slightly to be able to extract the most wind, just the same as a sail for a sailing boat. It just changes slightly to get the best wind so that they can go faster. And I guess at that point it does work the same on our turbine as a wind turbine. We have an amount of speed that we need the tide to be going at before we can generate any electricity at all, because below that there's not enough energy to get that torque and that twist that I was talking about to be able to generate electricity. But yeah, it's...
Need some strong tides up in Orkney, presumably, to get that going.
Oh yes. Well, you saw at the end of the video how strong the tides are.
Absolutely. Scapa Flow, was that in Orkney? For anyone that might be from up that way, just kind of see.
Scapa Flow is a place that we could look at, but we are at a slightly different site, slightly further north between two islands, at the island of Ide. If anybody wants to go and look at Google Maps for that.
Potentially some people from Ide could be listening to this, we never know.
Potentially.
That's it. Do we have another question coming in from John just now? Let's see. We do. Another one from St. Bridget's Primary, and they want to know, why do they call it O2? Maybe they should be teaching me something. I got the name of it wrong initially. But why is it called the O2, John?
I think this one is quite a simple one, probably disappointingly simple. O is for orbital, and 2 is for 2 megawatts. So the power rating of the turbine is 2 megawatts. So that's where we get the O2 from.
Simplicity at its best. Sometimes the best things are.
Yep.
There you go. Do we have another question coming in to follow that one up for John? We do. Another one from St. Bridget's Primary. They want to know, could the propellers harm any animals in the water? That's an interesting one.
It is an interesting one. One of the very first times that I was asked this question, I was at an exhibition in Glasgow for renewable energy. And right across from me was a marine biology stand. And I said to the person that asked me, look, I don't really know, but that's a marine biology stand and they're talking about these things today, so let's go and ask them. And so we went across, and the person that I asked there said, well, the chances of something going past the turbine while it's operating is quite small, because the water is so hard to swim in that area that there's not really any large animals that would go into that because it takes too much energy. So if you've ever been in a swimming pool when the wave machine's been on, it's really hard to swim in that area because there's so much energy coming towards you. And for animals, it's exactly the same. So there isn't a huge risk. Now, I'm not saying there's no risk. I'm not going to put that out there. And there are a lot of ongoing studies right now up in EMEC, up in Orkney, into this very question. But I would say it is low risk, but it isn't impossible. But I think the same can be said for many different energy sources as well. So we do our best to not have anything like that, but I think the speed of the tide is the thing that helps us the most. So
absolutely, and just one of the points I was just thinking of there, I don't know if it's the case with boat propellers, they certainly do a lot of damage, they're moving really quickly, whereas you said it's about 10 times a minute, was that right, for the rotation, so much slower? It's
much slower, but it's probably going with more force.
Yes.
So it's a heavier object coming a bit slower, but it still carries quite a lot of force behind it.
Of course, makes sense. Perfect. Another question coming in from John. Oh, we've got one from YouTube from Lisa Mitchell. Sorry, that's Bantaskin Primary P7, and they would like to know, how long will the turbine work for?
So the turbine will be in the water working for 20 years at least. That's the design life that we've put on it, is around 20 years. So yeah, it's quite a long life, but it's quite a big piece of kit. We took a year and a half to make it, and so we want it to last as long as possible when it's in the water, so that we don't have to replace it very often. So yeah, that's how long we're hoping to keep it in the water for, 20 years.
With so many companies as well, like you said, working behind it, you'd hope that they're all done their bit to make sure it's all ticking over for those long 20 years, hopefully.
and we, as I said before, we can go out to the turbine and we can inspect it and make sure that everything's doing what we expect it to do. And if there's something that needs replaced or fixed or something, we can do it very quickly on site, which makes it more chance that it will last the full 20 years.
And like you were saying in the presentation, a hang of a lot easier than sending divers or kit down to the bottom of the sea. Like with,
the other difficulty with that is because the tides are so fast, sending something down to the bottom of the sea in those fast tides means that you maybe only have an hour while the tide is changing, because it goes slower at the end and then speeds up again. So you don't actually have that much time to access the turbine either, which means that you generally would have to take it out, put it on a boat, fix it, or take it back to the shore and then bring it back out and put it in.
Wow. You can certainly see why it makes more sense now to have the design more maybe focused on the surface for the future as well.
Yeah.
Any other question for John? And we've got another one from YouTube, and this is from Davy. I don't know if I'm saying that right, Davy at school, and they want to know, how much does it cost to develop and build?
So this turbine, I think I can't give you an exact number, I'm afraid, but it is about the same cost per megawatt as offshore wind turbines at the moment. It's a little bit more expensive, but the thing with this turbine is that we made one. And when you order one turbine or one part, it can be quite expensive for one part, because somebody has to learn how to make it. They have to design the way that they're going to make it. They have to make the tools specifically for something. And you have to pay for all of that. But if you ordered 100 of them, they only need to make that tool or that design process or something once. And then it means that every part that you have after that is a lot cheaper. So this turbine was slightly more expensive than what the next turbine will be, because we already have so many of those tools available. And at that stage, we should be pretty much the same price as an offshore wind turbine.
Interesting. Ahead for the future, we'll see.
Yeah, so I hope that answers your question. I know it's not the exact cost you were maybe looking for, but it's all I can say.
Yeah, no cold hard figures.
Very
Excellent.
Political.
Yes. Okay, we've got another question coming in from the YouTube comment section, and that is from Mount Vernon Primary, and they would like to know, John, how powerful is the turbine? So how much electricity does it make?
So the turbine makes 2 megawatts of electricity. Now, that's a hard figure to understand what that actually is, but we say that is approximately 2,000 houses. So the electricity that would power, your TV, your computer, your Xbox, your charger, anything that's there, your heating and everything, for 2,000 houses. So, and that's one machine. So probably almost a small village would be powered off of it.
Yeah, you could say that. Just out of interest, just following on from that, with the power that comes off it that's generated for those 2,000 homes that you were talking about, John, how does the power get from the turbine to homes, to the grid, to the national grid, to get electricity? How does that happen?
So we have a really big cable that we plug into the bottom of the turbine. We have. So there's 11,000 volts of electricity that comes out of the turbine, and it goes down a cable that's very big, and it goes down to the seabed, and that cable is able to. That's called a dynamic cable, and it can move around and wobble as the turbine floats at the top, and that goes down into an anchor at the ground, which has a big connection on it and holds a stiffer, more rigid cable that then runs all the way along the seabed and over rocks and everything back to the shore and into the local transmission point there, and it's fed directly into the grid. So the houses where we are just now, the houses within 5 or 6 miles could be getting powered by this turbine. It's very, very local.
Absolutely brilliant. Yeah, I did wonder whether it was. I didn't want to be saying, is that a big cable? But it turns out it is a big cable. So. Perfect. Do we have another question coming in for John? We do. So that's another one. I can't remember which school it was, but teacher Lisa Mitchell, I think it is. And that is, what will happen with the turbine after 20 years? Will it be replaced?
Right. So this turbine, it may well be that we can replace parts of the turbine and then put it back into the water again, or it could end up being recycled. So we may do the opposite, where we take some of the parts off of it and use them on another turbine, or we just recycle the entire turbine, so that we can put it back into supply, so that the materials from this can be used again, and made into who knows what it might get made into. So those are probably the 2 options or 3 options that are available. I would like to see it that we could work on the turbine and, you know, give it a new paint job and you know, patch it up a little bit and show it some love, and then put it back out into the water to last another 5 or 10 years. But we'll wait and see. 20 years is quite a long time away, so
it is a long time.
lot of things could change.
That's right. Yeah, absolutely. There we go. Another question coming in here. We do another from St. Bridget's Primary, and they ask, what happens if rubbish gets stuck in the turbine? So this might be alluding to Blue Planet a little bit. We saw the documentary Blue Planet. They were talking about all the rubbish in the ocean. So there is rubbish in our seas, whether we like it or not, unfortunately.
Sadly.
So what would happen if any of that rubbish was to get stuck in the turbines?
So the way that the turbine is it's, because it's blades, there's not really anywhere for rubbish to get into the turbine. So I don't think that there are many places for that to happen. Now, you may see on the final image that we had on the turbine on the presentation, that when the water comes in, it scoots around the blade, so it gets sort of redirected. And there's a small area in there where it may, if it's floating, get caught up. And we can go out with a small fishing net, you know, on the end of a stick, and we can hook it and take it back into shore with us when we go out there. So there's no real threat to the blades or the nacelles or anything from rubbish getting trapped anywhere. It might just be that it's small amounts, maybe a couple of plastic bags or something around that one little area that we can probably go out and just scoop in. So
keep it nice and safe.
Good.
Brilliant. Hope that answers your question there, folks. This next question asks, what happens to the turbine in stormy weather? We certainly get a lot of stormy weather in Scotland. So how have Orbital been able to combat that, John? What do they do?
So we actually have a little video that shows the turbine in this environment.
Right,
so this is the previous generation of the turbine. This is the old one. And quite stormy seas up in Orkney there. And what we actually found was that the storms aren't quite as bad as you would expect on the turbine, and that the force of water when it's fully generating and the tide is at its full speed is actually putting more force on the turbine than a storm like this. So we're actually really quite okay in stormy waters. They look really bad, but we've got anchors at the front and anchors at the back that hold us really steady. And the design of the turbine is able to go across and float and move around a little bit so that we can take the impact from the waves, and we can survive them really well, actually. But it is a really good question, because it is a very harsh environment. Anybody that's gone outside on a really windy day knows how hard it is to walk in the wind, let alone try and be out on a boat in the wind. And so it is a really big design challenge, and it is something that we have to consider. So we do make the main hull, the tube section, is really thick metal. It's up to, I think it's 50 millimeters thick in places, to be able to cope with this sort of weather as well. So it is a design challenge, and it's something we thought of, and thankfully, from what we've seen, our design thoughts and the things that we spoke about earlier, where sometimes we get it right and sometimes we don't, but this time we got it right. So there, I hope that answers your question, and you enjoy seeing that wee video there.
It's actually quite, I was going to say, it's quite hypnotic just to watch it. I know, just going up and down like that. I'm guessing the anchor lines for it, John, similar to the dynamic electricity cable that feeds electricity into the grid. Does that move around? Because you can see it's obviously been allowed to move around a little bit. How much does it move? Like how held down actually is it?
I couldn't tell you an exact amount, but there's a small amount of play. So because we've got a forward anchor and a rear anchor, we can move, like if I do it this way, we can move a small amount here, but it's only maybe 2 or 3 degrees. So if you get your protractors out, you'll be able to see what 2 or 3 degrees looks like. It's not very much, but over 72 meters, it is, you know, a couple of meters in each direction. So it's not too bad. Up and down, it's really just lifting the weight of the chain, because if this is the vessel, the chain comes down and curves to the anchor. So when it lifts, all you're doing is straightening that chain. So it has to lift all of that up to be able to do this. So there's a bit of play, but not too much play. Because if we left it to really loose, then the turbine would be all over the place and there'd be waves hitting it in all places.
Might even be off to Norway, but would you go as far as saying that?
I hope not.
No, hopefully it wouldn't scale. Let's hope it stays where it is.
As long as it's still floating, then we're okay.
Absolutely. So we've got another question from the school there that says, wonder if there is any chance it could sink. So obviously a lot of vessels, boats and stuff do sink. Can the turbine sink?
I couldn't say that it couldn't sink. I think the last person that said that ended up with quite a sunken ship. So it is possible for it to sink. But what we do to try and avoid that is within the hull structure, we have a lot of doors. And those doors are really heavy doors that can keep water trapped in. So if a part of the turbine ended up with a hole in it, it would fill up between the doors, but it shouldn't be enough water in that section to cause the entire turbine to sink. So these things are called bulkheads. And we have, I think, 6 or 7 bulkheads all the way down. So that whole tube is split up into these sections all the way down. And if any one of those or 2 of those, depending if they're different ends, were to fill up, we would still be okay. But never say never, but it is something that we do have to think about when we are designing something that is floating, and we're hoping to stay there for 20 years. There is a risk, but yeah, we do our best to make sure that something like that can't happen.
Absolutely. I'm guessing if they were to fill up with water, it wouldn't be a case of having a bucket and start throwing the water out that was in this. It probably wouldn't be as simple as that.
No, we have a bilge system in it which pumps out the water for us. So it's an automatic sensor that starts a pump, and then it starts putting the water out.
Oh, brilliant! So automated to an extent, can kind of deal with problems. Brilliant.
Yeah.
Excellent. Okay, got another question, and that is, what got you into mechanics? So this is more a question about you rather than the generator drawing. That's what got you into mechanical engineering. Are there any memories you have from childhood that sparked your interest in it, and how and why things work?
My dad. So my dad is a marine engineer. He worked when I was a child fixing fishing boats on all the engines and the winches and everything that went along with that. And he now works for Caledonia and McBrain on the ferries on the west coast, fixing them and keeping those running. And so, yeah, when I was a kid, like summer holidays, I would be along working with him and going out on the boats and just getting involved in everything that was happening there, and coming home covered in oil and grease, because you get into everything, and it was brilliant, absolutely brilliant. So I've forever been surrounded by that environment and that line of work, and it really, that's the only thing that when I was looking at the end of school as to what to do next, it was the only thing that really, I could feel a connection with, because I understood it a little bit more. I worked on cars when I was growing up. My own car, I fixed parts on that. I fixed brakes and changed tires. I worked as a mechanic for a wee while as well. And just, yeah, I guess I've always just had this little bit of mechanical engineering always going on in my life, right from a young age. So that's what got me into it. But I know plenty of people that, they have had no connection to any engineering or of any kind when they were growing up, and they're still some of the best engineers that I know, because they've just had this awareness of the world around them and the problems that have been solved, and even just going out for a walk, the number of things that you can see that have all been engineered at some point in their history, be it the buildings that you live in, be it the roads, roundabouts, traffic lights, bridges, it's all around us. And just having that sort of curious brain as to how these things have actually come about and come into existence. These all allow you to get into mechanical engineering, and just, questioning things and being curious is the big thing that takes you onto that.
Absolutely. I mean, I'm not an engineer myself, but I couldn't agree more. That was a very inspiring and passionate answer. I'm sure a lot of people would agree that we're listening in there as well.
We need more. We need more engineers. The world can never have enough.
Absolutely, especially if you've got so many different projects and stuff going on with one thing, like you were saying. As well.
Yeah, so many.
Brilliant.
And the other thing though on that is it's not just engineering. It's all those other jobs that went into it as well. I mean, there's phenomenal jobs like being a welder, a machinist, working on, robotics would get you involved in making a turbine like this. There's a lot of electrical work that goes into this. There's really heavy bits of machinery, moving things around. It's such a variety of fantastic jobs that are really interesting and really involved and take a lot of skill to be able to do something like this. And it all just comes from that curiosity and that willingness to get involved in things.
Excellent. Really good take-home point for that for anyone listening. That's definitely stay curious.
Yeah.
I think that's we're actually coming towards the end. Unfortunately, John, I could probably sit and ask you questions for another half hour or so, but we are unfortunately almost out of time. So our last question for you that we've been that we want to know from a lot of our other guests for the live Q&As, and that is, what are your hopes for COP26 that's happening in Glasgow?
Yes, COP26 has unparalleled opportunity, but at the same time carries a lot of risk. It's a real turning point politically for the world, and I think the only thing that I can really hope for is collaboration between everybody that's there, that everybody wants to pull in the same direction and can see a consistent vision. It's very difficult without that cooperation for us to actually achieve things. Ideas like the turbine are fantastic things. All the different ideas for inventions that can change the world and help us make a greener planet, they're all fantastic. But a lot of the time, we need politicians to say, right, we can help you make this. We can invest in this technology and give you some money to help develop it and bring it forward. And until that happens, it is very difficult for anybody to come up with not just come up with a great idea, but to get it to go into the mainstream and be used around the world by thousands of people without some political backing and some financial incentives from there. And so if everybody that's going to COP26 or every country that's going to COP26 can agree that, on the very obvious that we do need to do something, and can actually commit finances and policies and things like that, and some of them maybe more boring things, but the absolutely necessary things to change the world that we live in. I think if they can collaborate on that, then that would be an absolute breakthrough moment in human history.
Excellent. I think we're all certainly counting for what you were just talking about there, and let's hope that it all kind of comes through when COP begins here in the next few weeks. Excellent. Yes. Thank you very much, John, again for joining us, and thank you to everybody.
For having me.
There, you're very welcome. Thank you, and thank you to everybody else tuning in. Remember, if you did miss anything from today's session, or you wanted to go back and maybe have a look at some of the questions that John's answered before, the video will stay up on Curious About Our Planet on Glasgow Science Centre's website, so you can have a wee look again at that. But all that remains to be said is thank you again for everyone for tuning in, and thank you again, John, and we'll hopefully see you all again very, very soon. Thanks very much.
Yeah, thank you.